Okay, in this video we're going to continue with the part D of problem number 4. And it says that at what time t, for t between 0 and 12 inclusive, is the volume of heating oil in the tank the least? And show the analysis that leads to your conclusion. So first of all, we know that we're looking for an absolute minimum here. We're working with a continuous function on a closed interval. There has to be an absolute minimum. It's going to occur either at a critical value or at an endpoint. For the endpoints at 0, we know that we have 125 gallons. And in part C of this problem, we have already determined that at the right-hand endpoint, we have 122.026 gallons. So next we need to find any critical values of the volume of oil in the tank. Well, we can use this new function, v of t, to represent the volume of oil in the tank at any time t. And so we started off with 125 gallons. Then we add the amount of oil that was that entered into the tank, and that's the integral from 0 to t of h of x dx. And our independent variable is t, so we use the dummy variable x with the h function. Then we're going to subtract out any oil that was removed from the tank up to time t, and that will be the integral from 0 to t of r of x dx. Now, we know from the second part of the fundamental theorem of calculus that the derivative of that whole v of t function is just the derivative of each piece. The derivative of 125 is 0. The derivative of the integral from 0 to t of h of x dx is just h of t. And the derivative of the integral from 0 to t of r of x dx is just r of t. So we subtract r of t. And so if we're looking for the critical values of the volume, we have the derivative of the volume now, and we want to set that equal to 0. And so to find the critical values, or the places where the derivative of volume is 0, where the derivative of the volume is 0, we can look at a graph of h of t minus r of t. And so I bring up the graphing calculator, I go into y equals, and I have entered this function y1 minus y2, which is in essence just h of t minus r of t. And notice that that's the only function that is highlighted there. So if I go to graph that now with a domain range from 0 to 12, you're going to see that v prime of t is positive, which means that oil is increasing in the tank up to this point here, and then it's decreasing after that, and then it changes from decreasing to increasing. So at this point we'll have a relative minimum, and at this point we'll have a relative maximum. Now, since a relative maximum can never be an absolute minimum, we really don't even have to pay attention to the critical value identified by where that crosses the x-axis. If I wanted to find it, though, it would be, I would use 0 and 0, 1, 2, 3. I know that it's going to be somewhere between 3 and 6. Guess. And it's at 4.79. And if I wanted to find the next one, I'd do something similar. Find a 0 between 11 and 12. Guess tells me that's at 11.318. And so what I need to do now is to test the original function v of t at the endpoints and at those two values. So I'll put away the calculator, and the first thing I write that is at v of 0 I have 125 gallons. At v of 4.79 I have a relative maximum. That can't be my answer. So I'll test at 11.318, and at the second endpoint, v of 12, I have already found that to be 122.026. Now to find the volume at 11.318, all I need to do, I'm going to bring back up the calculator, and from the home screen, actually I'll do this one from the graph, it doesn't really matter. I'm going to take the integral from 0 to 11.318, and add 125 to that. That gives us the absolute min.